So, yes, for Thursday, not tomorrow, the homework is to finish that homework page of 1.7, only the odds. You have a bonus point opportunity on the evens. The real life problems on that, there's examples in the notes key that is posted. We might not have time to go over them, but you can look at the notes. All right, so we left off at this picture. Composition of functions, you did this in Algebra 2. This is an actual thing that you do many, many places in your life. One instance is the vending machines downstairs, if they're ever on. Your first function could be putting the money in. That would be your original function. The second part would be pressing the button of your selection, whether it's a pop, Gatorade, or snack. And the combination of those two actions or those two functions would be your snack or drink that comes out, unless you have my luck and it gets stuck and then you have to shake the machine, which that would be like an f of g of h of x. Has that ever happened to you? Like, I have the worst luck. But when you are combining different actions and come up with one end product, that's a composition of functions. But if you forgot the domains on the homework over the weekend, you have to look at the domains for all the parts here. Your x must be in the domain of your second function, and then that domain has to be in the domain of your final function. It's confusing in words. It looks a lot better when we eventually do it. In that last graphic, the output of g of x is the input of f. The domain, this is not going to say fog. That little 0, it's not a 0, it's not an O, it's the composition math symbol. The domain is the set of all real numbers x, such that x is in the domain of g, and that function is in the domain of f. When we start looking at it, it will be a little clearer. But these are what the problems look like. They're going to give you individual functions, f, g, and h. Hopefully this is not the first time you've seen this. What this means is the composition of f to g. Whoever is closest to your x, that's who gets sucked in all the parentheses. Once you get that step, you should be good to go, because it's just easy plug and chug from here. What that means is for all the x's in f, plug in g of x. In my beginning, g of x is 1 over x minus 3. But you got that from the composition statement. It means you're going to plug in all the g equations every place you see an x in f. So here is f. The only x is the x squared. So what that means is I'm going to put in g's equation, or 1 over x minus 3, in for that squared. I haven't used the plus 1 yet. You did this when we did the difference quotient. You substituted in and simplified. We just now had to get to that part by recognizing what those symbols say. The key does not simplify. You could do 1 over x squared minus 6x plus 9 plus 1, or 10, but you don't have to. The domain, on our quiz, a couple of us tried to do it on the calculator and they got the wrong answer. Remember, if you have a denominator, you need to set that denominator equal to 0, and when you solve for x, that gives you the boundaries. Our domain can be anything that does not give us a 0 in the denominator. Therefore, our domain is negative infinity to 3 and 3 to infinity in interval notation. In set builder, and you can use whatever, as long as I don't specify, all real numbers x such that x can't be 3. Either or. But that's not hard as long as you understand what the composition means. What this guy means is you're going to plug in f's function for g. So since f is the closest, he's who gets eaten up by all the parentheses. f of x is x squared plus 1. So that means every place I see an x and g, I'm going to plug in f. Okay, so I'm going to do 1 over. Here is my x. Instead of that, I'm going to plug in what f is. And then I had not used that minus 3. Anybody remember doing this last year? Yeah. It was hard to get started, but once you learn the procedure, I think it's kind of just like the same thing over and over again. You're good. Who can tell me how to find out what I can have or can't have in my domain? What do you think, Kylie? Yeah. Set it equal to 0. And the one time we had to do this on our quiz, a couple of us forgot that when you actually perform the taking of the square root, you need both plus and minus the roots. And that makes sense. When I plug in a square root of 2 and square it, I get 2 minus 2 or 0. And the same thing for a negative. So that domain is negative infinity to the negative root of 2. It's everybody but those two roots. Everybody in between them, and then everybody to the right. Yeah. But the key is whoever is close to your x is who gets sucked in, and then that's just who you replace. Okay. Emily, do you remember this from 2 years ago, or is it kind of, how about you? Nope. Is it making a little sense? A little bit. Okay. Let's see here. You can't see my equations anymore, so I'm going to rewrite it for you. This guy says f of h of x. So since h is next, that means every place in f, you're going to put in the equation for h. On the front page, you can't see anymore. F is going to be x squared plus 1. And h on the front, what was that? The square root of x? Okay. So, instead of h of x, we can rewrite who he is. It's just, since they're equal, you can interchange them. And you did this on your homework last night. When you have f of something other than x, that means you replace it. So that tells me every place I see an x in f, I'm going to replace with what I have, and then rewrite what I don't use. So f of x was x squared plus 1. Instead of the x squared, I'm putting in the square root of x and squaring it. Check my algebra. Is that really x plus 1? Did I do it right?
Yes.
I think, right? Squaring a square. Can you spare a square? Well, check, because who knows? It's like my Monday here. Now, this has no restrictions for the domain, but at some point we had something we had to consider. Since it was a radical, I have to say that our domain is all positives. Since at some point in the problem we had something that needed a restriction, that's going to be our domain. Okay. Let's skip 3D and go to 3E. Yes, dear?
Sorry. For those square root, why would it not be positive?
Because I was not taking the square root. Like, you mean how they gave it to us? Or when?
Like for the answer, why would it be positive and for negative x plus 1?
Oh, because the square root, they gave it to us positive. When I square it, it's still going to be positive. So there's nothing like, we did not take the square root of something. That's the only time you put it in.
Okay.
The square canceled it out, and it was already positive. That's a good question. Very, very good question. Did I answer it okay? Okay. G of x. This is an ugly one. This is ugly because you're going to end up with fractions over fractions. Am I right in saying g of x was 1 over x minus 3? Okay. So since the G is next to the X, that means find the composition of G to G. Well, we know from the given that G of X is 1 over X minus 3. So that tells me every place I see an X in G, what am I going to put in? X minus 3. Yep, every place I see an X in G, that's what I'm going to put in. This is where it gets ugly. I'm copying the 1. Instead of the X, I'm putting 1 over the X minus 3. And then you have minus 3. This is algebra 2 at its high point. If I only look at that denominator, okay, over here I'm going to work the denominator. Do you agree the common denominator of that denominator is X minus 3? Right? So I'm going to have 1 over X minus 3 minus, to get that common denominator, I need to multiply top and bottom by X minus 3. This is the ugly algebra part of this. This is not the compositions. So the numerator becomes 1 minus 3x plus 9, or 10 minus 3x when I distribute and combine, and then the denominator I just recopied. And I can put that whole thing under 1. You're not going to have a lot of these. But reciprocating that, your final answer is 10 minus 3x. So if you are struggling with this, it's the algebra, not the composition. Would you have been able to get that on your own, do you think? No? It's kind of fun to watch it unfold. But the domain here has two things, because at some point you have to restrict your denominator. At some point, like this is in the denominator, and we have to restrict it here and then there. So x can never be 3 because it would give me a 0, and x can never be 10/3 because it would give me a 0 in the denominator. So these restrictions are also ugly because you're going from negative infinity to 3. 3 to 10/3, and then 10/3 to infinity. It's really just ugly. Yes, Kyle?
Is it good to write as 3.3?
Absolutely. I didn't specify. Now, we're not going to do 3F, but it's in the notes if you need it, if you need to look back. First, you're going to find G of H of X, which means you're going to plug in H for all the X's in G. And then you're going to take that answer and plug it in to F. So that's a trickery. It's going to be there if you need it. I have one more thing, and we'll be done. When you decompose functions, I think of a decomposing animal that smells really bad. Isn't that gross? That's where my brain goes. Vince, do you need me to go back, or are you okay? All right. When you decompose functions, you're going to have to think of what each function was, individual, before you got the final. So what this is saying is, what did the original functions f and g have to be so that when I composed them, I got the final new function. The new function h is a result of composing. So if I show you the first one, I think you'll get the gist of it. Do you agree that the inside is x plus 3? The outside had to have been x squared. So f in this guy would have had to be x squared, and g would have been x plus 3. So when I composed them, that told me to put x plus 3 in for x, and square. Can you see what they did? They're taking them apart. So here, for the next one, your original function had to be 1 over x. And your g of x had to be 1 over x minus 5. Or x minus 5, excuse me, not 1 over x minus 5. So that when I plugged that guy into the first one, I ended up with 1 over x minus 5. You're going to look at the outside and the inside. Can anybody tell me what one of them would have been? Kylie, tell me for this guy. You got it, yep. So F and then G. Last one. Oh, Kylie, you're on fire.
Inside of the x minus 2 and outside of the x squared minus 4x plus 5.
Okay, so you're looking to see what was substituted into the original. Very, very good. Now, in your homework, there are graphs to interpret, but I think you should be fine, and then real-world examples that you can use your notes to help you. But I think that's it. If I see you tomorrow, you'll